A very, very warm welcome to you to this, not just another episode of Makers and Movers. We have a very exciting topic today, and this is, I call it not just another episode because of three reasons in particular. But before that, I'll tell you why we have used the title that you see behind me, which is 3D printing, aka additive manufacturing, the way of future. Now, the phrase "the way of future" we have taken it is a take on the latest Avatar movie, which is called "The Way of Water." And obviously, as you would have guessed, the common connect is 3D technology. And I just came to know from Rajiv that the companies that do special effects for Hollywood for 3D printing or for 3D technology use Stratasys machines. So great. So I've got one more question in the kitty to add to many, many exciting questions that we have for today. So before I begin the discussion, let me share with you the three reasons why this is a very, very, very exciting episode. Uh, the first is the first reason is that this episode is about a technology which I personally feel and very strongly so, which is the next big thing after artificial intelligence in terms of its potential, its revolutionary impact on the world. The second reason is that we have perspectives from the biggest company in the world in terms of revenue for this panel. And the third reason is that we have two gentlemen, not one, but we have two gentlemen, two technologists, senior leaders from Stratasys, a double bill, as they say in Hollywood, for today's episode. Thank you very much, gentlemen. Thank you so much, Lei, for coming to our panel. Thank you so much, Rajiv, for coming to our panel. Just give me a minute to you guys need no introduction in the world of 3D technology. With our viewers in the machine tools industry, you've spoken to us on our panel. Just give me a couple of minutes to introduce you gentlemen and your background to our viewers. We have Mr. Lei Jin, President Stratasys South Asia. Mr. Lei Jin is the President of Stratasys South Asia with over 17 years of comprehensive achievements driving commercial excellence, business turnaround, and strategic growth in North America, Southeast Asia, and China. Mr. Lei leads Stratasys South Asia team to achieve higher growth of the additive manufacturing business in the region. Rajiv Bajaj, Managing Director, Stratasys India and Southeast Asia. Rajiv has over 20 years of experience in the technology industry. Rajiv leads Stratasys India and SEA team for the last 7+ years to drive sustainable growth of additive manufacturing in the region. Rajiv has extensive experience in the manufacturing industry in driving business transformation and has been a speaker at leading industry forums like CII, ACMA, and IMTMA on driving innovation through technology adoption in aerospace, automotive, and consumer goods industries. I'll start a discussion now, and my first question is to Lei. Lei, can you share with us, viewers, your experience of working with Stratasys India's South Asia team, with your teammates, with your customers, and the market overall that you have seen so far? Lei, over to you.
Yes, thank you, Mr. Rana. Thank you for having me on the show, and I also thank the listeners and the viewers for joining, and hoping you guys are able to hear what we want to share today. First and foremost, I also want to thank Rajiv for inviting me to this as well. Rajiv, has been with the Stratasys for many years. He's a senior leader within the company, managing the Southeast Asia and India region, and we believe he's leading the charge in 3D printing into the market and working with our customers very closely. And just kind of maybe share a bit about my experience in the region. I'm currently based in Shanghai, managing the South Asian region. And the customers that I've met so far in India, in China, in Australia, New Zealand, Southeast Asia, are automotive, aerospace, healthcare, general industries, and education. And what we see in the market is that 3D printing is supporting our customers and our partners on how to get to manufacturing in a way that was never experienced before. And how they do that is, we're not here to replace traditional manufacturing. We're here to augment the manufacturing process and to support the manufacturing process. And we help our customers by getting to their solutions and solving everyday challenges. And I think everybody's familiar with 3D printing. And again, we're not here to replace. We're here to push Industrial 4.0 and maybe get it closer to Industrial 4.5.0 for the future. So that's kind of what we see so far in the market. And that's kind of what we are wanting to achieve. And I'm sure Rajiv can add a little bit more for India and Southeast Asia.
Yes, Rajiv.
Thanks, Anand. It's always a pleasure to talk to you. And I think Blake pretty much covered about the experiences. I think India is no different from the geographies in Asia, particularly. And in some ways, we are leading the market with the adoption that has taken in with some of the leading healthcare organizations and even in the manufacturing side of business. And we will talk about it as we go along.
Now we come to the part that our viewers have been waiting for. Now I have taken the liberty to do a little bit of research on 3D printing. So at the risk of sounding a little techie before the technological leaders that we have for us, and please do correct me, gentlemen, if I'm wrong. There are 5 technologies I hear that are at play in 3D printing. Let me very quickly read them out to you because I don't remember, obviously. One is polyjet, the other is FDM, the third is stereolithography, the third is DLP, which is digital light processing, and the fifth is powder bed fusion technology. So, gentlemen, can you share with us the real life use cases of these technologies and their distinct respective advantages? Lay.
Hi, yes, maybe I'll let Rajiv take this one. Rajiv?
Sure, no problems. Well, good research, Anand, and these are definitely the topmost technologies that are there in 3D printing. Essentially, 3D printing is all about depositing either polymer or metal layer by layer. It happens in multiple ways. Either you have a resin that is spread like a 2D printer, and then you cure it with either UV or laser, and then prints up layer by layer. Then the input could also be a heated filament in a heated chamber where you melt that filament to give the desired shape to the plastic, one layer at a time, and builds up the thing. You could also use powder like nylon and give output in multiple formats. Now, every technology has its own key advantages, distinct features, and to some extent, not so good features. So depending on whether a person wants to use color, very fine features where you will use polyjet. If you want to use big fixtures and very big prototypes, you would typically use a technology like fuel deposition modeling, which incidentally co-founded by, not co-founded, which was essentially founded by Scott Crump about 30 years ago, and that's when Stratasys was found. He was trying to make a toy using a modified glue gun for his daughter, and that led to an establishment of a multi-billion-dollar industry through fuel deposition modeling.
Wow,
and
thanks
then
for
we
that
have
appreciate that on
Thanks.
behalf of the youth. Yes.
Yeah, and then through other processes, the whole idea about 3D printing and technologies is how we can make the output faster, cheaper, and give user the same part features, if I would say so, as a traditional manufacturing would be. So trying to bridge the gap between traditional manufacturing and additive. Additive by nature is, you can design and drive as much innovation as you want, but how do you make it effective at the end of when you meet 1,000, 10,000, or 100,000 parts? So that's how the technology is progressing.
Like?
Yeah, I think in terms of technology, again, we're not trying to solve the biggest problem that's out there, right? We're here to, one, how to support our customers or partners to go from traditional manufacturing to innovate from the traditional, I guess you could say, answers to manufacturing, and augment that process and augment that solution, making sure that they can reduce costs, reduce their time to market, and make things a bit more efficient. I think at the end of the day, that's Stratasys' vision, that's our goal, and that is to move into manufacturing production and make sure our customers have a solution that's able to get them to the lowest cost, the fastest to the market, and able to get to their customers' hands. So I think that's, I won't talk too much on the technology side, but that's kind of the vision that we have for this business.
Gentlemen, can you give us some examples of the FDM technology, for instance, to begin with, that also the story of which also lies at the foundation of your company? The FDM technology, what are its uses? What are its advantages? How is it being used in the world? Lay?
Yeah, again, I'll let Rajiv cover the technology side, but I'll give a bit of kind of what I see in the region in terms of FDM case studies. So when we work with automotive companies, such as the biggest one, BYD, Volkswagen, BMW, or FAW Holding, which is a Chinese firm, we see FDM technology implemented in the jigs and fixtures. How jigs and fixtures is able to aid them in their production needs, and as car models are changing ever faster than before, what used to take 7 years to change a model is now changing 12 to 14 months in the China market. In China being the largest electric vehicle manufacturer in the world, with 15-20% market penetration, it's important, if not more important than ever, for our OEMs to gain more market share through faster innovation, faster modeling of their future models. And we see this being applied in automotive, and we also see this applied in traditional industries, general industries, whether it be tier one, tier two suppliers for our large OEMs. So, for example, for again, another automotive supplier for automotive glass, they use jigs and fixtures to improve their manufacturing process. They also use FDM to print rapid prototyping, R&D related. And we also see customers printing through FDM technology actual parts, production parts inside a car. Now, with the advancement of electric vehicles, people are no longer competing on engine size, right? Is it a V4? Is it a V6? Is it a V8? Now it's 0 to 100. It's 4 or 6 seconds. Not a big difference for a consumer. Now, what they're looking for is how comfortable is my car inside? Is it safe? How do I personalize the car? Do I want my name 3D printed on the leather? Do I want my name printed on the dashboard? How do I make the car lighter through technology so the battery life is longer? Right? So these are things that we are seeing in the market, and these are challenges that Stratasys is addressing with the technology that you mentioned, which is the FDM, the PolyJet, et cetera, et cetera. So this is kind of what we see in the market.
Thanks, Lay. Rajiv?
And just to add to whatever Lay said, similar business challenges, just to give you some Indian names, from companies like Volkswagen India to Lear to Bharat Forge to Hero Motocorp, TVS, all of these and multiple tier one suppliers are using FDM technology as a part of their core product development process. Because the technology is a very well established technology in terms of repeatability, reliability, and throughput, it has really found its way deep into prototyping, also deep into jigs and fixtures, and some point of end-use parts manufacturing. We have over I would say 250 customers in India using this technology very successfully on similar lines of cutting cycle time, faster to market, and driving new innovation.
That's great, and it's interesting that you took the names of companies that are working with you in India, with Stratasys in India. Yeah, Rajiv, you mentioned about one particular use case which was really interesting, and it has stuck with me. Was with AIMS, with if I'm not mistaken, Dr. Suri that you mentioned the name of, and Stratasys has been working with AIMS, and their doctors and researchers have been using your machines for something that I've forgotten. It's been a long time since our last talk, but I'd like you to elaborate on that use case for our viewers, please.
I should, and since the last time we spoke, we have added two new exciting names to the medical list. One is a hospital called Akash Healthcare in New Delhi, Dwarka, and the other is an institute called Sabita Dental that runs medical colleges and also affordable dental treatment for its customers. And both of them are also, besides Dr. Suri, who is of course a very renowned personality in the area of neurosurgery in the world. They are using our specific printer called digital anatomy printer, which helps mimic the exact human tissue and human anatomy to help surgeons cut down complicated surgical time, as well as in some cases make patients from inoperable to operable to healthy. So we saw a case in Akash Hospital. Lay and I were there 2 days ago, where a small girl had a spine which was almost S-shaped, a spine instead of being straight. And conducting a surgery on the spine is a very serious process, because one wrong move, one wrong nerve touch can make the patient paralytic. and it's a very complicated one. So what they did was during the surgery, they designed 3D printed fixtures on our machine, JH50 DAB, which will limit the extent to which the surgical instrument will go, so that no wrong nerve is touched, and they could actually make the patient the surgery successful instead of some 18 odd hours that they had mentioned to in about 60% time they could complete the surgery. So lesser surgical surgeons fatigue, successful outcomes, and there are many more cases developing every time we meet the neurosurgeon or someone using our technology in medical. We come to know of a new use case where we have not the technology has not only helped save lives but also made a healthy living choice for the individual patients.
Wow, wow. I mean, the gold standard for any technology to me personally is that when it actually saves lives, when it actually helps out in critical conditions, mission critical conditions, and the use of 3D printing technology in healthcare, which is really taken off. At least I'm coming to know of it in the last 2-3 years. And one particular, obviously, case which I think has proven to be its inflection point, so to speak. It's a use in the pandemic, and I'll turn to the two gentlemen as to what their experience has been. And 3D printing technology, as our viewers know, we have spoken in the past, how Stratasys in particular opened up its platform, material platform, its software platform to developers, to engineers, to technicians, to help them make masks and shields to save people from the pandemic. Lay, can you tell us your experience about how the pandemic uh, was for the company, how it stepped in and stepped up to help out people with masks and shields?
Yeah, that's actually an excellent question. And I have an example coming out of China again. FAW Holding Group, which is one of the largest state-owned enterprise in China. They essentially are the major shareholder of all automotive joint ventures in China. It all falls under that umbrella. That's some background information on the scale. And during the pandemic, when there was a lockdown that happened in Shanghai, our team, Bobby, who's in charge of our automotive sector and our AE, because we were unable to meet the customer, we actually did the whole development process online through online interfaces. We worked with a design firm. The customer told us this is the design they wanted for their interior, whether it be the gear shift, whether it be the dashboard, the door, the leather. They gave the design to a design firm. We worked with the design firm. We printed the design from the firm, and we were able to bring reality into their blueprint, and we shipped that to the customer in 2 months. The 2 months meaning from start to finish. And the customer said, this is somehow we were able to make life or bring to life what they wanted, what they had in their mind. So I think this is, again, what 3D printing can do when there is a supply chain crunch or supply chain issue. And when there isn't, this is also a way for people to cooperate remotely, which means we bring additional innovation to the market, we bring additional collaboration to the market. And this is another example of us not trying to change manufacturing traditional, but again, augmenting the process, augmenting the experience, and allowing innovation come to life. So this is something that we see that happened during the pandemic.
Thanks so much, Lay. What has been your experience, Rajiv, about this?
So during the pandemic, we had some of our large customers like Volkswagen, Hero MotoCorp, turning the entire use of their 3D printing into making masks and devices to protect human lives. We also went ahead and gave free access of our experience center to a few colleges who were working on ventilator design. We moved a couple of our machines to colleges in Bangalore, the regional college in Bangalore, and it really successfully helped them uncover some critical needs during the time of COVID.
Yes, I do remember that time, Rajiv. You and I got to speak when we had the lockdown situation happening all
Yes.
around us, and we turned to you and other industry leaders in because at dynamic manufacturing we were kind of groping in the dark as to what is going to happen to the industry, and you said that these things are happening, which gave us so much hope and courage. Uh, and we were so delighted to be a part of this industry for that reason.
Correct.
Thank you so
And
much
also
for
kudos to the automotive industry who
this.
kind of completely took out of all
Yes,
other innovations and put it on saving lives for critical cases during the time.
is that so? Can you shed a little light
You
on
know, I
that?
mean, I have an example from Volkswagen in Pune.
Okay,
Of course, Hero Motocorp also did something. Maruti developed ventilators, but closer
okay,
home in Pune,
okay.
they worked with Decathlon from some snorkeling device to convert it into a mask and things that
Wow,
patients can use. I mean, there is a case study I could share with you sometime later
please do.
where they
Yes.
talk about how they did it successfully.
Wow, wow. That's really great. Uh, Another instance, another use of it that I kind of want to bring up is the aerospace industry. The reason I bring this up because we've been covering the aerospace industry quite a lot in the recent past, particularly so because India and particularly Karnataka and Bangalore is has emerged, and it has already been a very strong traditional hub for aerospace. Uh, Now, for aerospace, 3DP in particular is doing many exciting things. And one thing that I connect between our talks with you, Rajiv, and with aerospace industry leaders is the use of composite material. Now, this has really taken off in the last, if I'm not mistaken, last over the last decade, where people have not certainly have been going on for quite a while the R&D, but because of the new technology, people are now able to experience to experiment with material. It is said that, please correct me if I'm wrong, that 1 pound saving of 1 pound from or cutting down of 1 pound from the weight of an aircraft saves about 1,000 gallons of fuel, jet fuel a year,
Correct.
or something close to that. Uh, so it's a huge thing for cost saving, particularly sustainability and for Paris climate goals. So my question to you gentlemen is the use of 3D printing in the aerospace industry and how it is helping the industry reach its sustainability goals. Lei, what has been your experience?
And another great question. It's touching upon another industry that we are very focused on, and where 3D printing is uh, being challenged at the same time providing solutions to our customers. I think aerospace, where we see composite materials being leveraged, is non-flight critical parts. So something such as a air duct, right? The air duct that we see on the plane, those are being optimized to reduce weight, as you mentioned, and that reduction of weight will reduce fuel consumption at the same time impacting the ESG for corporations. Two, we also see when 3D parts, because the complexity that's able to print is able to reduce the weight of a certain part because of the complexity. For example, for a certain part, we may not need it to be solid. It could be hollow, or it could be a matrix. It could be a lattice. And because 3D printing is able to print that complexity, is able to optimize that part for the airline or for the OEM and reduce weight again. And finally, the 3D printing allows them to do less volume production. Instead of printing for automotive, where you need to print 1,000, a million, 10 million gear shafts, crankshafts, you can print 30, 40, 400,000 parts for an airplane. And they're able to do that by saving, able to do that by doing it internally without outsourcing it to the company, which is higher cost. And we see a lot of this. And we also see where within airlines, there is a shall we say, confidentiality. They do not want to outsource certain blueprints and parts to a third party, and they do that in-house. And this is something that they feel really comfortable with. So these are some of the things that we see in the aerospace industry.
Fascinating, fascinating. Thanks so much, Lei. Rajiv, your thoughts?
Quite aligned with what Lei said. And another area that is emerging is MRO for aircraft. I mean, besides lightweighting, they also need flame, smoke, and toxicity resistance in the materials that they use. So FDM as a technology serves them very well. I mean, when cases, in special cases where aircrafts are 30, 40 years old and they sometimes the suppliers are not there, some window handles, some trays, and this and that. People are actively using the additive way and making sure that planes fly, and then there is less burden on the airlines. So it's becoming a very interesting use case as we go along in the industry.
Great. Uh, Now, we have a lot of viewers who come from the machine tools industry. So I want to ask you, gentlemen, about its uses for the machine tools industry. But before that, I have one more important topic to cover. Now, we recently had the chance to listen to one podcast where the CEO of Stratasys, Mr. Yao Zef, please pardon me if I'm not able to pronounce it correctly, uh, spoke about its uses. And one thing that was really interesting to me was uh, how it reduced the supply chain complexity of the US Navy. Apparently, there was a project where uh, different teams had to manufacture parts in different parts of the world, and the 3D printing machines connected seamlessly and on a very secure connection, and printed the same parts at different locations in the world. So I thought that was hugely interesting. So my question to you, gentlemen, is that how is 3D printing being used to reduce the supply chain complexity, which again reduces the carbon footprint that goes into transporting things and storing things? How is that being used in the world, and what are its potential advantages? Like,
Yes, I can't particular comment on the Navy part. I think that's probably quite confidential, but I can give an example where, you know, 3D printing is alleviating supply chain pressures. Um, you know, for example, we had companies where, because of the cost that they face with traditional injection molding, traditional jigs and fixtures, they set up 3D printer centers of excellence. And BMW is one of them. And they have they made it a very top-down decision where 3D printing is a critical part of their everyday manufacturing process. And they put the machine in the middle of the factory floor and said, we need to print jigs and fixtures. We need to find ways to print in order to reduce, one, our communication inefficiencies, meaning let's not have Germany do the design and then we localize. Instead, let's do the design in Asia, and then we can print the parts locally and we can use it locally for a local market. BMW China, BMW India, BMW North America, and EMEA are very different. They have local taste, local demands. The cars, to some extent, are similar, but the personalization of the cars are different, which requires different tooling. And this is where 3D printing is very critical to their manufacturing process. And this is where we see you don't get the back and forth shipping of it tooling from North America to China or to India to do a copy and paste. And this is where you see the impact to kind of the ESG figures that most companies have to report. So that's one example of reducing supply chain pressures through 3D printing.
thanks so much, Lay. Rajiv, your thoughts?
Yes, so a couple of points about additionally about supply chain is one is that you don't have to set up a plant to use 3D printing, so you can always manufacture closer to the point of sale. That is becoming additional point. And in these days of uncertain border conditions and the wars going on, it is becoming more and more important for people to have their either self-sufficiency in manufacturing or closer to the point of sale in terms of it. That's one area that we are solving. Another very interesting area that I have learned from our own customers is dual manufacturing. So suppose they're manufacturing 1 lakh parts for OEM. Now the company needs 1 lakh 10, 1 lakh 20, 1 lakh 100. So do they put up a new line for those 100 parts, or there is a faster and easier way to manufacture that? And that's where 3D printing fits in seamlessly. And more people are experimenting with it. And then it becomes, I mean, up to a few hundreds or a batch production of a few thousand, it becomes a very viable process for them to use 3D printing instead of setting up a new line for manufacturing.
Now we come to the topic that our viewers have been waiting for, and not in vain, because they would have listened to so many interesting points being discussed. The machine tools industry is a great place, is a great industry to be using 3D printing technology. But unfortunately, particularly in India, for a number of factors such as, let's say, labor arbitrage and a lot of things, where industry is a little more on the cautious side when experimenting with new technologies. Now, my question to the panel is that, one, in what ways can 3D printing technology be used? For example, they very quickly mentioned, because I find it interesting from that podcast, Mr. Zaif mentioned that the tools can be made safer, for example, uh, uh, for the workmen, for the work, for the shop floor staff, for
Right.
instance. So what are the various uses in which 3D printing technology can be used in the machine tools industry? And the second and very important question is how? Mr. Lay, over to you.
Yeah, so I think I've heard one case where, again, this is automotive related, where during the manufacturing process, you have a person standing there and checking the quality of certain parts that go through. And they are on a very strict schedule of a couple of minutes or a couple of seconds, but 30, 40 seconds per car. And they need to check the dimension of a certain part. And this gentleman, he is actually wearing a belt support for his back, and he's carrying a 10 to 50, 20 kilo measuring machine that checks how flush the part is against a certain piece. And we were able to print something that is much lighter for him to use, and that is able to reduce work fatigue and increase his ability to provide quality work throughout the 8 to 10 hour shift that he's working. So these are some things that 3D printing is able to do by improving maybe the work and health and safety part of their job. So we do see that in manufacturing at the safety level. In terms of the tooling, I'll let Rajiv maybe talk a bit about that topic.
So, but one important point I want to talk about this is, I mean, we met Dr. Sarvan and the CTO of Ashok Leyland day before yesterday in Chennai, Leh and I, and he mentioned that though a lot of progress is happening, but in manufacturing we are still about 10 years behind where we should be today. And I kind of agree with him, and attributes to the adoption of technologies, Industry 4.0, and so on. So what's happening in the machine tool industry also is, when we speak to some of the large manufacturers, the Indian manufacturers today, is that the customer today is not just looking at one simple CNC machine or 10 of machines. They are looking at a line automation. So when they go to OEM like a Hero MotoCorp or a Maruti, they tell the process that they want and the outcome they want, and whatever goes in between, including the machine tool, the robotics, etc., they need to design for them. So in that area, 3D printing is playing a large role now. A few things like end of arm toolings, for specific tasks, pick and place robots, and so on and so forth. So that's an area which has become very integral. Quick to make, quick to reproduce, don't hold large inventories, and so on. The other part is in terms of failures if it happens on the line. So from Honda cars, we heard an example. They were using a very advanced robo, and its arm broke. And when they asked the Japanese manufacturer to give them a replacement, it was costing them something like 30,000 US dollars and 3 months of lead time. But they were quickly able to reproduce that using 3D printing at 1/10 the price and within 3 days. So these kind of innovations. So once you have a 3D printer, it's like a tool which you can extrapolate your thought process and get to design and manufacture things that you are not doing using the traditional processes. So I think machine tool industry with time would become a large user of 3D printing technology as they move faster towards Industry 4.0 implementation in large organizations.
Wow. This brings to mind another question, which I'll be taking up the next question, because the other question is a high altitude question, and I want to stay on the ground, on the micro topics, micro issues. Now with machine tools, a very interesting thing that has happened uh, for all product sectors is that Stratasys opened up its software and material platform for developers. Now that is hugely interesting to me because I find something equivalent, something similar in the artificial intelligence story. Is that when NVIDIA, which has been a major platform for the development of artificial intelligence, and it became so big when it opened up its platform for developers to use its chips, which would otherwise be used for, which originally were thought to be, were intended to be used for videos. Right. And when the developers started to use it and they started to use for artificial intelligence, which absolutely took off. So that reminds me when we talk about Stratasys opening up its platform. So pardon me, gentlemen, for these two very distinct comparative points, but I do find something similar here, that 3D printing could take off because of this. So what are your views about this opening of the platform, Rajiv?
The whole idea about this, Anand, is to democratize 3D printing, right? You want to give more and more access to people to customize the way they want to use our 3D printers. And one of the key areas of focus for us as an organization today is our software capabilities and how we are giving easy access of the entire printing process to the end customer. A customer may be having multiple technologies, multiple machines. How do we integrate that into their actual MES system? So that's one area we want to do. And when we opened up our materials for 3D printers, the idea, I mean, till so far, 3D printing, one of the biggest challenges that 3D printing as an industry has been struggling with is the choice of materials that you want to offer to the customer, right? So because of the limitations so far, our users were not our, but globally from all 3D printing customers or 3D printing manufacturers, the customers were limited to the use of materials that we were manufacturing or the 3D printing manufacturers were manufacturing. Now, the idea today with opening up is that we will let users experiment with the materials of their choice. So we are partnering with large global manufacturers like Evonik, BASF. We ourselves acquired a company called Covestro, which is a large material supplier. The idea is to let customers design using the nearest equivalent, no, the exact material that they want to use using 3D printing.
Like your thoughts?
Yeah, I think, if we look at software material, those are two critical components to the customer journey. One addresses how customers innovate, and the other addresses how customers use a certain conduit to address their application needs. So I think software opening up allows for a wider access, which grows the 3D market, 3D printing market, and allows for people to get access who never had access before. It's kind of a similar concept to what Tesla's doing with their electric vehicle, right? They opened it up for everyone so that they can get more adoption for electric vehicles. And same thing with 3D printing. With software improves interface, user experience, and it gets people to start using 3D printing. Two, with material, I think as we bring more material, it really allows the designers and the innovators to have more options. It allows them to play and figure out what material is the best for their challenge and what material can really be used in their manufacturing process that can be used to go to market and launch and commercialize their products. So I think Stratasys, being a leader of industry, we want to make sure these things are open. And by opening, we bring in more people that can join the party, so to say, right? And we can bring more people and material into this industry to grow the industry so we can push, again, Industrial 4.0, maybe to Industrial 5. And then this is why I think Stratasys is doing
So, Lay, my related question to you, and I'll put this on the panel, is that with AI, speaking of AI, do you see that 3D printing has found an ally in AI? And if it is so, what are the directions into which you see 3D printing going? For example, a better simulated design, for example, which could help 3D printing invent or manufacture new material with better artificial intelligence and better libraries and better data. So how do you see this a symbiosis between artificial intelligence and 3D printing going into the future and doing greater things, Lee?
Yeah, I think that's a very hot topic nowadays, AI. And I think 3D printing, we are agnostic to what can really elevate 3D printing to the next stage. We want to work with innovators, we want to work with companies, and we want to work with people that can elevate 3D printing. AI, I don't have a crystal ball in front of me. I wish I did. I would probably win the lottery. But I think AI, how it can help is the data. I think data is where through AI we're able to gather how our partners, our customers are using 3D printing, where they're using it, obviously with the permission from them, and we can leverage that data to improve the process, to improve what they're trying to do, and give information back to the partner and the customers. Say, hey, this is how we can maybe make this part more efficient. Maybe we can reduce the speed, increase the speed. We can reduce output, increase output, et cetera, et cetera. So this is where I can see potentially AI contributing in terms of 3D printing. But with the evolution of technologies these days, everything changes so quickly that it's hard to say where it can and where it cannot. But we definitely keep an open mind to technology in order to, again, elevate 3D printing.
Ajit?
Very similar to what like said. I mean, it is more towards possibly making the entire process simpler. I mean, do you really need to learn all the CAD and designing, or you can design using AI in a faster way, giving them just the boundary conditions? This is what I need. What will be the best product design for something like this? And shift to 3D printing. When we are printing, can we do some in-process monitoring? Can we correct some errors if there are on the printing process, or even give us the best material that would be more conducive to the product design that we are taking? This is what possibly next 1 or 2 years, but then down the line possibilities are unlimited like any other sector, I would think.
Absolutely, gentlemen. You nailed it. To my mind, AI and 3D printing. At some point, I envision a robot, making fixing his broken arm or her broken arm all by herself. Reaching out to 3D printing and getting it made in Terminator style. But that vision is too dark, and I hope that doesn't happen. Great. So my final question to you gentlemen is a high altitude question, and it gets talked about so much, and this is about awareness. And now it's an important thing. It's an important topic about 3D printing, because when it started out, 3D printing, I remember is that everybody thought they could have a small little nifty 3D printer for themselves, and they could manufacture, good and bad things with their own 3D printer. And this perception about 3D printer stuck in people's minds, and it still does to some degree, to a significant degree, at least with the end users or with consumers outside the industry. That one, 3D printing is something that is to be that everybody can use, that is meant to be used by an end user or a consumer to print something that they need for themselves. And two, the quality of it is not great, is what they have seen on social media and other places. So my question to you gentlemen is that this perception has come in the way. So I think to my mind, it's the biggest barrier in the way of 3D printing really deserving to going to where it deserves. So how are you fighting this perception about 3D printing? Lay, over to you.
Yeah, I think I think I wouldn't say it's much of a fight for perception of 3D printing if it's a quality or bad quality. I think it's one, getting the customers to understand what is 3D printing. That's number one. And number two, really getting them to understand what are the capabilities of a 3D printer, right? And if they understand what the capability of a 3D printer is, then then we can share with them a different discussion on, okay, this is the capability. Is it aligned with your expectation? And then we can have discussion, okay, can we address the challenges that you as a consumer or a innovator or designer is expecting from a 3D printer? And we can work together through that process. So I think this is where we want to take a look, focus a bit on. At the same time, I think if you have an idea of where you want to go with the 3D printing process, you do your homework and understand, as a consumer, hey, which brand do I want to take a look at, right? Whether it be this brand or that brand, understand what each brand, their technology is, and then work with the brand, work with the company on how you want to design, how you want to manufacture, and how you want to print. And I think through that process, you should get to a destination where I can't say you're 100% satisfied with it, but you should be satisfied with it. And if you're not satisfied, continuously reiterate, iterate, right? I think that's the whole concept of 3D printing and technology.
Thanks so much, like Rajiv.
Sorry, just a second. I think there's some problem with my speaker. Can you hear me?
Absolutely, loud and clear.
Okay, fine. Yes. Thanks. Similar to what Lay said, it's about also the perception and the limits. When some people thought you press a button and everything gets done on the other side of the 3D printer, to some extent it is okay, but some bit of work beyond that. And also there is a distinct difference between what is an industrial 3D printing versus what is a consumer-based 3D printing. So if somebody has seen a production quality output and he thinks that he or she can achieve the same with entry-level 3D printing, that may not be the case. But entry-level 3D printing is a very good concept for people to explore, experiment, and then move on to higher levels of 3D printing. So there's no wrong or right for this perception or question, but it's an evolution, I would say.
Wow. Okay. Great. So that sums up and that answers all the questions that our viewers have. This technology, dear viewers, is the next one, as I said, after artificial intelligence, and Lay and Rajiv, you guys are doing a very great and very useful work. My best wishes to you for your responsibility. This is the next big thing that is going to transform for India in particular. Gentlemen, this technology is very important for us to go into Industrial Revolution 4.0. Thank you so much. Have a brilliant day, Lay. I hope that you enjoy your India visit. It's great having you on panel. Thank you so much, gentlemen. Take care.
Yes, thank you. Thank you very much. Thank you for having me.
Thank you.
Thank you, Anna. It's always a pleasure to speak to you, and thank you for spreading the message of additive manufacturing and other advanced technologies. I am a regular viewer of your other shows also.
Wow. Okay.
Among Indian consumers and customers. It's a great thing that you are doing.
Fight on, man. Thank you.
Thank you. Bye-bye.
Bye-bye.
Thank you. Bye.
Yes, come, Sushmita. Sorry.
Oh, okay.